Hi everyone, this lesson is for Algebra 2 honors students. This is Chapter 4, Day 5, 3x3 Systems of Equations, and specifically Section 4.6, Multivariable Linear Systems with 3 variables. So let's get started. The first thing that we're going to do is a little bit of a warm-up, and we're going to start with a piecewise function, meaning we're going to be graphing two different functions on the same axis and try to find out try to solve for these values, okay? So first we're going to do is we're going to graph the first equation. The first equation is saying f of x equals 3x minus 5, and so that's an equation of a line. I'm going to try to make this a little bit bigger so it's easier to see. Okay, so in doing this, we're going to start at negative 5, so 1, 2, 3, 4, 5 right here. And our slope is 3 over 1. So we're going to go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1, etc. 1, 2, 3 over 1. Okay, so this is a line that looks like this. Okay, now this line, which is f of x, is equal to 3x minus 5, is just that line. However, when you put in the values of their restrictions that they gave you, which says x has to be greater than 4, well, if x is greater than 4, we're at, let's see here, 1, 2, 3, 4, so like here, so right around here, they're saying that at 4, my graph has to be more than that. So it can't even equal 4. So whatever I have here at 4 is like an open circle because I can't have a value there. So what it's actually even looking like is there's no value here. And then anything to the left side is like gone. Does not exist. Okay, so we're going to get rid of that. And then the other equation is f of x equals x squared. Now that's a parabola, right? And we all know parabolas do this kind of thing like that, right? So if I were to take that parabola and put it here, right? Well, what's going to happen is x has to be less than or equal to 4. So it actually doesn't want any values or it does want a value at 4, but nothing, you know, more than that. It's got to be less than or equal to 4. So let's try to figure out what's happening at 4. So I'm going to delete this little parabola and try to be more specific in that if I were to plug in, let's say, just like make a graph, and I said, well, what's happening at 4? Well, 4 is, this is x squared, so that would be 16. So at 4, I'm actually way up here, solid value 16. But keep in mind that this value now is going to be less, everything else is going to be less than that, right? Because at 4, let's say this is 16. There's my point there. They want everything less than that. So if this eventually were to keep going, right, over and over and over, they don't want that. That's out, okay? So now what we do is, now that we've graphed this function, still a function, right? And keep in mind there's no value, oops, hold on, this value here, that's not there. Okay, so there's nothing past 4 for my parabola, and there's nothing to the left of 4 for my line. So now that I've graphed this piecewise function, parts of it, right, I'm going to plug these values in. So f is 7. So I'm going to plug in 7 for, now, which equation do I plug it into? So that's what you have to decide. If I plug it into this left side, right, there's no values there because 7 is over here. And if I were to plug in 7, I can only plug it in to the line equation. So that means I'm going to go f of 7 is equal to 3 times 7 subtract 5. So 21 minus 5, which is 16. So f of 7 is 16, which means that 7, 16 is actually a point on my graph. So if I go over 7 and up 16, there's a point on my graph. F of 4 we're not going to use the line equation because remember, for the line equation, x has to be greater than 4, but not equal to 4. So the only one that I can use for 4 is actually this one, the x squared. So, and we've already done that. So we know that f of 4 is equal to 16. So that means I have a point at 4, 16, which is right here, which we already knew. And then lastly, we have f of negative 3. So f of negative 3, now that needs to be plugged in on the left because negative 3 is over here, right? So the only graph that shows up on that left side is my parabola. So I'm going to say negative 3 quantity squared, which is 9. So the point that I've made is negative 3 comma 9, which is, you know, around there. So our objectives or learning targets today are with our 3x3s, meaning we're going to have 3 variables and 3 unknowns. Whereas before we were doing 2x2s, we were doing 2 equations and 2 unknowns, and we were looking for an intersection point, or we were looking for parallel lines, or we were looking for like the same exact line. Now for a 3x3 is a little bit different because with a 3x3, you have 3 variables, which means not only do you have x-axis and y-axis, but now you have a z-axis. So let's think about that, okay? These are my little markers here. So what we have is, here's x, right? Orange is x, and this is y. What happens with x, y, z is here's x. And so what happens is x, right here, moves out front. Y becomes x, and here's z. Z then becomes this value that kind of looks like y, right? So let me do that again. Here's x, and here's y. What happens with an x, y, z coordinate system now, 3x3, is this x value pops out front like this, okay? Y now becomes x, z pops in here, and z becomes all-powerful Zeus up on top. All right, so that's what we have. We have an XYZ axis. So now that you have an XYZ axis, and what you need to do is you need to be able to figure out what is the intersection of the 3 planes, because these aren't points anymore, they're actually planes. Because how many points do you need for a plane? You need 3, right? And each one of my XYZ is going to give me 3 intercepts, and those 3 intercepts make a plane. Okay, so it's like, we're like, I hope you're thinking geometry, oh, it's all coming together. Okay, hopefully. So the methods that we're going to be using is, I'm going to briefly show you how to solve a system by the traces, which are basically the planes. It's like a trace is like a slice of the plane. And I'm going to show you back substitution. And I'm going to show you Carl Gauss's elimination method. And I'm going to show you, and those are for, like, I'm going to show you how to solve a matrix. And then also, we're going to be using CRAMER'S rule to be able to solve a system like this. So I want you to look at the plane. On the right-hand side of the screen, you're going to notice that it's like a folded something and then a plane here. Those are 2 planes and then another plane. I'm looking for that intersection point. Okay, now realistically, remember in geometry, your teacher or you learned that you only needed 3 points for a plane, right? Well, something similar to that looks like this. It's like a trace, right? So what happens with this is like the 3 points that you would need. It's like a slice of the plane. And so your job is to try to find 3 of these, because each equation, like a 2x plus 3y plus z equals 5, that's a plane. That right there is an XYZ, right? That's 3 points, three intercepts, which are going to give you points that make a plane, a slice of a plane. Because remember, planes like go out and they go on forever. So that's what we're looking for, is what is that little slice, okay? So what I've done is, and it's very similar to a 2x2. You know, in a 2x2, when we were solving those, and we were solving those by the graphing method, those are like our most unreliable methods, right? The graphing method, because it's, you know, you've got all these fractions, you've got this and that, all these issues, right? Graphing method is not as reliable as one of the other methods that we can actually use a formula or solve or subtract or use a CRAMER'S rule, etc., with the 2x2. This is a method that you're just drawing the 3 traces. So basically, the objective is to choose one equation at a time and try to find the intercepts. Now remember, with a 2x2, if you're trying to find the x and y intercept, like if you're trying to find the x-intercept, you set y equal to 0. If you're trying to find the y-intercept, you set x equal to 0. Well, let's try to find the x-intercept for this first, and I'm just looking at this first equation, okay? I want to find the x-intercept. So I'm going to set y and z to 0. So those are gone. So now I have 6x equals 24, right? 6x equals 24, so that means x equals 4. So here's x. X pops out that way. So go 4 out. Here's 4. So now I want to find, so I found the x-intercept. So now I want to find my y-intercept. So to find my y-intercept, I'm going to set z and x equal to 0. So I have 4y equals 24. So in this case, y is equal to 6. So go out 6. So here's 6. All right, now lastly, to find the z-intercept, I'm going to find the z-intercept, I'm going to set x and y equal to 0. So these are gone. So I have z equals 8. So let's say 8's right here. So we've got x, y, and okay, so what we're going to do is, if you notice, I'm going to connect these and check it out. That right there is a trace, meaning that is a trace on my graph. That's like a slice of my plane. Because remember, you only need 3 points for a plane. Check, did that. So now what I'm going to do, and remember, planes go on forever and ever. So this is just a slice of it. So the next one I'm going to look at is this one right here. Okay, and for this problem, this one is nice and easy, right? Because to find the x-intercept, these go to 0. So x-intercept is 5. I'm going to use a different color. So x-intercept is 5. This is positive x, that's negative x. This is positive y, positive z, negative z. So x is 5, check. And then I want to find the y-intercept. So I set x and z equal to 0. So y is also 5. So that's going to be, oh no, I'm in the minus. Oh, here we go. Here we go. There's 5. Sorry about that. And then to find the z-intercept, z is going to be negative 5. So that's going to be down here somewhere. So for this trace here, right, this trace is going to look something like this. Okay. And then to find the last equation's trace or slice of the plane, we're going to set each one of these. We're going to find each one. So if we're going to find, the first thing we're going to do is we're going to set these equal to 0, and we're going to get 2x equals 6, so x equals 3. So x is 3. That was 5, so it's in here somewhere. To find the y, I'm going to set x and z equal to 0, so I get y, it looks like I get y is equal to negative 2, and then z is going to equal 6. So y is negative 2, so that's over here, and then z is 6, so we'll say that's there. So what you're doing basically is I'm trying to find the intersection of the 3 of those planes. Now, where is it, right? So basically, this is the most unreliable method. I mean, like, it looks cool and stuff like that, but it's like, where is it? And so, like, I actually want a value that's going to point right to it. I want a vector, you know, I want some place that's going to point, this is the point. And so let me show you how to do that, because this is like, this is just, you know, graphing the 3 traces on one plane and on one axis and try to figure out where the intersection point is. And remember, when we had a 2 by 2, right, a 2 by 2, we were looking for the intersection point, which was x, y. However, for a 3 by 3, we're looking for the intersection point, which is x, y, z. All right, so we're going to start with back substitution, and this is solving a 3 by 3. We have 3 equations. We have 3 unknowns. We're going to have an intersection point at x, y, z. So we have x, y, and z. So the first thing we're going to do is, well, this is z is 2. Well, we know 2. Well, we already got the first point. There it is. Okay, so now I've got to find x and y. Well, if z is 2, I'm going to back substitute that into z. So we're going to have y plus 3 times 2 equals 5. So y plus 6 equals 5, subtract 6. So I get y equals negative 1. So that's this value right there. And then lastly, I've got y and z. So I can just plug these values in. Or realistically, I have y and I have z. I could plug it in. Yeah, that's not what I want to do. I'm going to plug it in on the top here. So we've got x minus 2y. Y is negative 1. Plus 3z. Z is 2. And that equals 9. Okay, here we go. X plus 2 plus 6 equals 9. 6 plus 2 is 8. and I'm going to subtract 8 from both sides. So I get x equals 1. So then my intersection point is this value right here. Now that's way easier than graphing the 3 traces, right? But I do want to show you graphically like what that actually could look like. I'm not going to graph by the 3 planes. I'm not going to do that. The way I'm going to show you for this problem, z, negative z, y, negative y. I'm going to show you this with a vector so that you can kind of see where the actual point of intersection is on this axis, XYZ axis. So x is 1, so I'm going to go over 1. There's 1, so I'm going to go this way 1. Y is negative 1, so I'm going to go out this way parallel with this. So there's y is negative 1, and then z is 2, which is up 2. So realistically, my actual intersection point is right there. So it goes from 0 to this value here. There's a little vector that points to where my actual graph is. And one way to show the planes is actually to make a little prism here. See this, like that? And, you know, these go up like this. Who are my little artists here, right? This goes like this. So this is actually this box kind of thing that's sitting right on the axis, okay? So it's like sitting right there. And that vector goes to the actual point of intersection for the three polynomials. So this point right there, that's it. That's the point of intersection. So like if I was graphing this with 3 traces, the place that I would have the intersection would be right there. I know, that's kind of cool, huh? I guess I could finish my box. Okay, anyway, let's keep going. This is just basically back substitution, showing you exactly what I just did. So, totally fine. Now I want to show you Karl Gauss's elimination method with a 3x3. Now I know we did an elimination method with a 2x2. Let's do elimination method with a 3x3. And so I'm going to add just, first I'm going to eliminate x's. You guys, you have to decide what you're going to eliminate first. For me, I always like to eliminate the x's if possible, and so I'm going to add row 1 and row 2. So row 1 plus row 2 is going to be x plus negative x. That's gone, so that's 0. And then I've got negative 2 plus 3y is going to give me 1y. And sometimes, I will say this. Do you see here? There's no value here. Plus no z, okay? So you can put a value there, like as a no value there, and that might help a little bit. So when you add these two, I'm going to actually just rewrite these. X minus 2y plus 3z equals 9. I have negative x plus 3y plus no z is equal to negative 4. Add these two equations up. My x's cancel. Negative 2 plus 3 is y. 3 plus no value is 3. And then 9 minus 4 equals 5. So there's my first equation. So now I'm going to combine 2 more equations. I guess I'm going to do the bottom 2. I guess we can do that. That's fine. Combine these 2. And so that means that I'm going to multiply this equation just by 2. So I'm going to get negative 2x and then 2 times everything. 2 times 3, which is 6y. 2 times no value is no value. And then 2 times negative 4 is negative 8. And then I'm going to get 2x minus 5y plus 5z equals 17. I'm going to add these two equations together. Cancel that. 6 minus 5 is 1y. 0 plus 5 is plus 5z. And then I've got negative 8 plus 17 is going to give me 9. And so now I have this equation, y plus 5z equals 9. Now you have to try to combine those two equations. So in doing that, so I've got 2 equations, 2 unknowns. So now, because the y's are the same, I'm just going to subtract. So, and be careful though, because one of the biggest issues that I see is that kids forget to distribute that negative sign. So just be careful in that. So y minus y is gone, 0y. Yes, you can write 0y, don't. Because those are gone now. 3 minus 5 is negative 2z. And then 5 minus 9 is negative 4. And then I'm going to divide both sides by negative 2, and I should get z equals 2. So there's my first point. So for my x, y, z, right, for my intersection point, x, y, z, z is 2. So now I'm going to plug this into either one of these equations. I'm just going to pick this one since I haven't messed with it yet. And we're going to go y plus 5 times 2 equals 9. So that's 10. So I'm going to subtract 10 from both sides. I'm going to get y is equal to negative 1. So now I've got y, which is negative 1. Now to find x, I'm going to go back to one of the equations, and I'm going to figure that out. So we're going to go, I'm just going to pick the top. Let's just choose the top. Okay, and so we're going to get x minus y. So we're going to go x minus 2y, so minus 2 times y, which is negative 1, plus 3 times 2 equals 9. So we go x plus 2 plus 6 equals 9. So 2 plus 6 is 8, and I'm going to subtract 8 from both sides. So what was this, 9? Okay, so we've got subtract 8, so I get 1. So x equals 1. And just a note, it is always a good idea to check your answers, especially if you have an equation. So like this one is missing some values, but I'm going to try this equation just to make sure that I have the right answer. So I'm going to go 2x, so 2 times 1 minus 5 times y, y is negative 1, plus 5 times z, z is 2. 2 plus 5 plus 10, 10, 15, 16, 17. So I got 17 and then equals 17. So we have our answer. So our answer is 1, negative 1, 2. And just note that if like I wanted to graph this right on as a vector, then I would go I would go 1 in the x direction. So that would be 1 this way. It would be a negative 1 this way, and 2. Very similar to the last problem that we did. Or is it the same problem? Anyway, very similar to the last problem. And yes, then I would make a box here, right? And then put my my values here. And then that vector, which is that value right inside there, being this point right here, is the point of intersection. So I mean, like, it's definitely a cool drawing, right? Okay. This is just me doing the same thing again, just showing you a different way. This is the textbook showing you a way to do it. Also, I have something in my eyeball. Sorry about that. Okay, and then the last way. So I've showed you a 3x3 graphing method with traces. I've showed you a 3x3 back substitution, where you start with a value, small value, and then you plug it back in. And I've shown you the Gauss elimination method for a 3x3, but what I haven't shown you is a 3x3 Cramer's rule. I did show you a 2x2 Cramer's rule, but not a 3x3. And the rule is for 3x3 for Cramer's rule is once you set everything up like super nice and in order, right? There's a formula, and this is the formula, but I kind of like use a sort of variation of that, meaning you always start in the top left-hand corner, and once you rewrite the first 2 columns, you are going to multiply down to the right, to the right, to the right. But when I multiply down to the right, I'm basically going this plus this plus this, and then I subtract a sum, this plus this plus this. Whereas it looks like here that they went minus, 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 which they've distributed it at the same time, which is totally optional, up to you. So here we go. We're going to start off with this determinant, and I'm actually going to rewrite this determinant like this, just because I just like it better like this. So negative 1, 2, 2, and this is 4, 1, 1. Okay, so this is a determinant, okay? It's a 3x3 determinant that we're going to solve. Okay, so here we go. The way you do this is the first step is you rewrite the first 2 columns, okay? So we're going to get 2, negative 1, 4. See, the columns go up and down. So I'm rewriting the first 2 columns. And then 3, 2, and then 1. Okay, check. Rewrote the first 2 columns. So now what we're going to do is you start in the top left-hand corner always, okay? Put yourself there. And what you do is you multiply down right. Okay, so we're going to go 2 times 2 times 1. What is that? 2 times 2 is 4 times 1 is 4. Plus 3 times 2 times 4. So 6 times 4 is 24, plus 0 times negative 1 times 1 is 0. And then we subtract and we go the opposite direction, okay? So then we go 4 times 2 times 0, which is 0, plus 1 times 2 times 2, so that's 4, plus 1 times negative 1 times 3, so that's negative 3. And then you basically just add those up, okay? Ow. And, got a mosquito. Okay, so that's, 28, subtract 4 minus 3, what is that, 1? So 28 minus 1 is 27, which means that this determinant is 27. Done, okay? That's fun. So the next one, we're going to do this again, and we're going to, again, rewrite the first two columns. So 1, 0, 3, negative 5, 2, and negative 2. Okay, so we wrote the first two columns, and now we're going to multiply. Start at the top left-hand corner. This is you. Okay, here we go. 1 times 2 times 2, which is 4, plus negative 5 times 1 times 3, negative 15, plus 2 times 0 times negative 2, 0. And then I'm going to subtract, and I'm going to go back the other way. So we're going to go 3 times 2 times 2. So 6 times 2, that's 12, plus negative 2 times 1 times 1. So that's negative 2, plus 2 times 0 times negative 5. So that's 0. And so now we just simplify. What, right? 4 minus 15, that's negative 11, minus, and then 12 minus 2 is what, 10? Yeah, so negative 11 minus 10, which is negative 21. And I'm done. So like everybody's favorite number a few years ago. Okay, so what we're going to do now is we're going to put this all together, okay? And with Cramer's rule, this handsome man here is Gabriel, and Gabriel came up with this really cool way to solve a 3x3, not by back substitution, not by graphing method, not by elimination, but by Cramer's rule. And so, right, so we are going to solve this by determinants, and I know this is going to be one of your favorite methods, just like mine. Okay, so we're going to start off, and again, best case scenario, you guys, is just start off like writing everything out like that, right? So, okay, so we're going to have our little determinant on the top and one on the bottom. Super cool, right? Now remember, we did this with a 2x2, and now we're doing it with the 3x3. I know you're going to love this. Okay, so this, remember, this is the box, just like it used to be, right, with the 2x2, but now this is a 3x3. So we're going to put our coefficients in here. So we have 1, negative 2, 3. We have negative 1, 3. Oh, 0 there, right? No value, no value. Plug in a 0. Then we have 2, negative 5, and then 5. Now, for this part up on the top, if I'm solving for x, that value goes right in the x column. Remember, columns go up and down. So we have 9, negative 4, and then 17. And then these numbers actually get brought up, right? Okay, because I'm not solving for those, so they just come up. Okay, so we're going to go negative 2, 3, and then negative 5. These just come straight up. So then we have 3, 0, and then 5. And so now, remember, I have to rewrite the first two columns. So in doing that, okay, I'm going to go 9, negative 4, and 17. Then I get negative 2, 3, and then negative 5. Now rewriting the first two columns on the denominator, again, we have 1, negative 1, 2, and we have negative 2, 3, and negative 5. So for this, okay, right, we've rewritten the columns. Okay, so now we just have to multiply, so this is fun. So remember, start in the top left-hand corner up here, right? And then we just multiply and add. So here we go. 9 times 3 times 5. Yeah, might need a calculator. So what is that? 27. You guys probably can do this in your head. 27 times 5. I get, what is that? 135. Probably need my glasses. So here we go. 135 plus negative 2 times 0 times 17. Gotta love the zeros. Gone. Plus 3 times negative 4 times 5, negative 5. So that's what? 12, negative 12 times negative 5, and that's positive 60. And then close that and subtract, right? And then we're going to subtract another quantity. Now, what is that? 135 and 160? Is that 195? Okay. All right. So now we're subtracting going the opposite direction. Okay, so here we go. 17 times 3 times 3. So 17 times 9. 153. So we have 153 plus negative 5 times 0 times 9, 0. So that's gone. Plus 5 times negative 4 times negative 2. So that's what? 5 times 8, which is 40. So we've got 153 plus 40, which is 190, 153 plus 33, right? Okay, and then 195 minus 193 is 2. So, right? And that's positive. Yep, so 2 over some other value. Okay, so now what we're going to do is we're going to do the bottom. And in doing the denominator, again, you start in the top left corner. So you're going to go 1 times 3 times 5. So that's parenthesis 15 plus negative 2 times 0 times 2, which is 0, plus 3 times negative 1 times negative 5. So that's 5 times 3, which is what, 15? Subtract, go the other way. So now we're going to go up. So, I don't know, let's use purple. So we're going to go 2 times 3 times 3. 6 times 3 is 18, plus negative 5 times 0 times 1, which is 0, plus 5 times negative 1 times negative 2, 10. So that looks like it's 28. And 15 plus 15 is 30. So 30 minus 28 is 2. 2 divided by 2 is 1. X is 1. Right on. Okay, so that means we found X. Okay, right? So this is like super fun. All right, so now you want to find Y and Z. So to find the Y value, what we're going to do is we're going to plot the points like this, right? Or not the points, but we're going to put our matrices in there. And as we do that, I'm going to put the values on the denominator there just so that you know that they're there, but technically you really don't need that because you already know that the denominator is 2 from the last question, right, where we knew that this was 2. So realistically, you know, you don't have to do that. So what we're going to do is we're going to take this 9, negative 4, and 17, and I'm going to put it in x, y. So that'll go 9, negative 4, and then 17. And then for the x value, right, that would be here, like 1, negative 2, 3, right? That 3 would go up, 3, no value, and then 5. 2, what's this? 3, negative 5, and that's negative 2. So then 1, negative 1, and then 2. So these would just be brought up. So we have 1, negative 1, 2, 3, 0, and then 5. So we're going to rewrite the first two columns, which are 1, negative 1, and 2. And then negative 2, 3. Oh, wait a minute. Hold on. I'm doing the denominator, actually. So we have 1, negative 1, 2, and then we go 9, and then negative 4, and then 17. So that when I multiply across, so, right, 1 times negative 4 times 5, that's negative 20, plus 9 times 0 times 2, which is 0, plus 3 times negative 1 times 17, what is that, negative 51? So negative 51. And then subtract, go the opposite direction. So 2 times negative 4 times 3. So that's negative 8 times 3, which is negative 24, plus 17 times 0 times 1, which is 0, plus 5 times negative 9. So that would be negative 45. So let's see. Negative 45 and negative 24 is negative 69. Minus negative makes plus. And then this is negative 20 plus negative 51, right, which is going to be 71. So negative 71 plus 69 is negative 2, which makes negative 1. So y is negative 1. So I can go back to this part, and I say, okay, there we go, negative 1. So you kind of get the idea. This is like, yes, it's a process, but it's, it's kind of cool. It's a formula too. In order to find z, and I'm just going to use the top. I'm just going to make the determinant on the top, and let's see how we do on this, right? 9, negative 4, and then 17. And then the values on the bottom here I'm going to bring up. So what I have is 1, and this is negative 2, and we go negative 1, and we have 3, and then we have 2, and then we have negative 5. And those are the values that brought up, okay? So for this one, rewriting the first two columns is 1, negative 1, 2, negative 2, 3, and negative 5. So, okay, 1 times 3 times 17 is 51 plus, and then negative 2 times negative 4 is 8 times 2 is 16 plus 9 times 5. That looks like it's 45. Yep. Minus, go back. So we've got 6 times 9, which is 54, plus, that looks like it's 20, plus 20, plus, and 17 times negative 1, negative 17, times negative 2. So negative 17 times negative 2 is 34. So using my calculator for sure, even my glasses, let's see, this will help. We've got 51 plus 16 plus 45 is 112. Subtract 54, subtract 20, subtract 34, I get 4. And so that means that the numerator is 4, but don't forget the denominator, right, for x. Down here, that denominator is 2. So 4 divided by 2 is 2, which then means that 1, negative 1, 2 is my intersection point. And so therefore, what we would do is just to check our answers, right? Pick one of these or two, right? And actually, we just did this problem, so we know that we have the right answer. So for me, just always check your work to make sure you have the right answer. And tonight, you have 3 problems for Cramer's Rule. And I do expect you to use Cramer's Rule. Good luck. And it does say one of each, doesn't it? So that means that we're going to do 1 Cramer's Rule. You can do 1 back substitution. And then you can do 1 elimination. And then that would be fine. All right, thanks for watching, and I hope this helped.